On combine protein mapping, we've been at this for a few years. For those of you watching who saw this presentation at the Prairie Grains Conference, at first thing that morning, I apologize, this is going to be the same slide set since I wasn't able to add anything else of interest in the last month. So apologize for that. But for those of you who maybe haven't seen some of this yet, we'll give an explanation of what we've been looking at. So basically the premise behind this, we have been working with a company and a couple machines that are mapping protein at harvest, and we are able to get a grain protein map that looks just very similar to a yield map. And so now that we are able to see and map this protein variability, we can now go in and start exploring its relationships with yield, soil, fertility, elevation, other things going on in the field. And so we can see that depending on the field and different soil characteristics or environmental characteristics that we got going on, we can vary several points across a whole field. And so that also invites the question of protein management. And so thinking about what influences protein content, it's an interaction between genetics, your variety, the environment that you're growing in, and your management. And boiling it down, the two biggest things that are going to first things that are going to affect your yield and your protein are going to be available water and your available nitrogen, which is first going to influence how much yield you have, how much starch you accumulate, which is then going to influence how much protein you have, how much nitrogen is taken up into the plant and converted to protein, and how much starch is in that kernel, diluting the amount of protein in that kernel. And so we were able to see that we were able to see that variability across the field. So thinking about how we can management, so we've got things that are out of our control and things within our control. Unless you're growing irrigated spring wheat, things out of our control are going to be how much water your field gets and the type of soil and your soil characteristics that you're farming in that field. Things within our control are going to be variety selection and nitrogen management, the rate of nitrogen that you're putting on, the timing that nitrogen is going out and that it's available, and your management by soil type if you are managing on a zone level. And so just kind of trying to apply those concepts to what's going on in these fields. So if we've got a field that's got a sand ridge running through it and how that's affecting yield and then in turn affecting protein. And so it's behaving in many cases inversely as we would expect, high yield, low protein, low yield, high protein. But in some areas we get kind of that sweet spot of high yield or good yield and good protein. And so trying to hone in a little bit on more about why that happens or what's causing that. So that's why we're studying protein variation, trying to discover, what's affecting it most, and then turning that information and trying to use our nitrogen more efficiently so that we can increase our profitability. Those management zones, we might try to use them to increase our yield or increase our protein, but really we want to make sure, I think, we're using our nitrogen most efficiently to be most profitable, get our biggest return on investment on that field. And so if we can identify what's our biggest influencers, and if those influencers on variability can be managed, we can try and come up with some different options of what we can do. And so that's what we've been doing for the last couple of years, mapping protein for multiple, trying to accumulate multiple protein maps on the field, so tracking things as they go through the rotation. This year we added monitoring kind of depth to water table and a few selected fields, also capturing drone and satellite imagery on those fields soil sampling and texture characterization of those fields. And the most difficult part of this project for the last few years has definitely been the spatial data management and analysis of working with that data and trying to come up with some meaningful results. That's definitely been a sticking point here that we're trying to work through. So quick, if you haven't seen this, how the analyzers work. So we have a sampling unit located on the clean grain elevator that's attached to a spectrometer that's in the cab. And then you're able to control that and also watch protein map as you're harvesting on the in-cab monitor. So that's kind of what it looks like set up here. The grain kind of falls in from as it's going up into the clean grain elevator, it falls into the sampling head. The light gets shown through and collected here in this fiber optic cable, which is then sent to the spectrometer that's the brains of the instrument in the cab. And then you're able to see that up here on the monitor. We've been working with 2 cooperators, one in Pennington and one in Roseau, mapping their fields for the last few years. We've got a lot of loams and sandy loams, and we've also got some clays mixed in there. So we've got a good spread of soil data to be looking at and mapping. This year we added some water table monitoring, just trying to pick in a few fields to just measure the depth to water table at a few different elevations within that field to kind of tie it to that available water component of our protein or influences on protein variability. And then so we're just continuing to look at how topography affects protein and yield, how our nitrogen fertility affects yield and protein, and how it might be an indicator telling us, using protein as an indicator of how our nitrogen, our fertility level, our fertilizer rate is doing. Are we just right? Are we too low? Are we a little too high? Maybe need to pull it back. So trying to use the protein as an indicator of our nitrogen management plan. Looking at imagery, tying that to our protein zones. We got a protein rich strip here in the top half of this field. And looking at it with, just looking at the patterns and relating it to our maps. Now that we are starting to accumulate, go through the rotations in these fields, we can also start looking at zone stability and whether the zones are shifting or whether maybe the areas, the zones are static, but their response in the season varies depending on what the season is like. And again, that's another example of kind of our zone stability, how the general areas might be changing, but their response, so those, the response, whether you get high protein or low protein, might change depending on your environmental conditions for the year. So we're going to continue mapping, trying to collect as many maps as we can and trying to work through that spatial data analysis to come up with something useful for growers to look at, combining that with imagery and how you might be able to use that on your farm, whether it's through variable rate application maps, or if you happen to have the space and the ability to segregate protein, maybe being able to map and segregate your protein and market it based on current prices, proteins, premiums and discounts.